Hello friends, grab your coffee, grab your cookie, and please do not charge up any static electricity while we talk today, because our topic is plastic dust. Yes, the dust that somehow manages to stick to everything except the inside of the dust collector. My name is Michael Klepik, and I have spent 15 years working with air filtration systems for plastics, composites, polymers, and every kind of material that melts, grinds, shreds, or extrudes into something useful. Let me break down what plastic dust is and why it can be surprisingly difficult to control. What plastic dust really is. Plastic dust is a collection of very fine polymer particles produced when plastics are cut, ground, sanded, milled, shredded, pelletized, or recycled. Typical particle sizes range from 1 micron to several hundred microns, depending on the process. What makes plastic dust unique is this. First, it is extremely lightweight and stays airborne for a long time. Second, many plastic types create strong static charges. Third, some plastic dusts are combustible under the right conditions. Fourth, the particles can be fibrous, flaky, or fluffy, making them difficult to filter. Fifth, some plastics release additional vapors or fumes when heated. Plastic dust looks harmless, but its behavior in air systems can be unpredictable, especially with static buildup. Where plastic dust appears in industry. Plastic dust is produced in a wide range of operations. Here are the most common ones. First, grinding and granulating scrap plastic. Second, cutting, trimming, or routing plastic sheets. Third, CNC machining of acrylic, polycarbonate, or composites. Fourth, plastic recycling systems that shred or pulverize material. Fifth, sanding and finishing fiberglass reinforced plastics. Sixth, pellet handling, bag dumping, and pneumatic transport of plastic pellets. Plastic dust can also appear during injection molding, extrusion, or thermoforming when surfaces are trimmed or shaved. Why plastic dust is dangerous? Plastic dust presents several hazards at the same time. First, it is a respiratory irritant, especially smaller particles below 10 microns. Second, it builds up static electricity, which can cause shocks or ignite combustible particles. Third, dust from certain plastics, such as polyethylene, polypropylene, and ABS, can be combustible. Fourth, fiberglass dust and composite dust can damage the lungs. Fifth, dust from plastic recycling may include contaminants, dyes, or additives. The combination of static, airborne particles, and combustibility makes proper air handling absolutely critical. How I capture plastic dust at the source. Capturing plastic dust requires proper hood design because the dust is light and easily escapes. The most effective capture methods are: first, enclosed tool hoods on CNC routers and milling machines. Second, side draft hoods for sanding operations. Third, fully enclosed grinding rooms for high-load processes. Fourth, pickup points located directly inside shredders, grinders, and granulators. Fifth, capture hoods on conveyor transfer points and recycling lines. Plastic dust requires higher duct velocities than heavy mineral dusts. I typically design air velocities from 4,000 to 5,000 feet per minute to prevent material from settling inside the ductwork. What filtration equipment works best? Plastic dust has a wide range of particle sizes. This is why I use different collectors depending on the process. For fine plastic dust, I often use a FOEHN cartridge collector because, first, it handles fine and lightweight particles very efficiently. Second, it offers large filtration area in a compact footprint. Third, it is easy to pulse clean when dust does not clump. For mixed or fibrous plastic dust, when the dust includes fibers, flakes, or composite material, I prefer the Baghouse Blizzard. First, it tolerates heavy loading. Second, it handles irregular or fibrous particles better than cartridges. Third, it is robust, reliable, and easy to maintain. For combustible plastic dust, if the plastic type is combustible, I add: first, explosion vent size for the collector. Second, grounding and bonding to eliminate static buildup. Third, an isolation valve for safe duct protection. Fourth, anti-static filter media, static electricity. The hidden enemy. Plastic dust is famous for static electricity. Here is what static does. First, it makes dust cling to every surface except the filter. Second, it interferes with airflow and causes uneven deposition. Third, it can ignite combustible dust if a spark occurs. Fourth, it can overload sensors, valves, and electrical components. To eliminate static buildup, I always use: first, grounded ductwork. Second, anti-static filter bags or cartridges. Third, proper bonding between all equipment parts. Fourth, metal components where appropriate to dissipate charge. Without grounding, static makes the entire system unstable. The most common mistakes I see with plastic dust. Across many facilities, I see similar issues repeat again and again. First, using undersized duct velocities, causing lightweight dust to settle. Second, trying to collect plastic dust with equipment designed for heavy materials. Third, ignoring static electricity until it becomes a problem. Fourth, mixing plastic dust with metal dust or wood dust in the same collector. Fifth, failing to use anti-static filter media. Sixth, operating grinders without fully enclosed pickup points. These mistakes reduce efficiency and increase safety risks. What I always do on plastic dust projects here is my standard approach. First, I verify whether the plastic type is combustible. Second, I calculate duct velocities specifically for lightweight dust. Third, I use enclosed capture hoods whenever possible. Fourth, I select either cartridges or bags based on particle shape. Fifth, I include grounding and anti-static protection in every design. Sixth, I choose the correct discharge system, since plastic dust can be fluffy and difficult to handle. Seventh, I ensure that the system is easy to service without dust escaping. These steps create a stable and efficient system. Plastic dust may look harmless, but it is lightweight, airborne, full of static, and sometimes combustible. With proper airflow, grounding, and the right filtration system, you can control it safely and efficiently. I am Michael Klepik. Protect your lungs, protect your equipment, and keep your plastic dust inside the filter, not floating around like confetti at a birthday party. See you in the next video.